Hello and welcome to the Edupedia world. In this tutorial, we are going to study data structure shortest path problem. Okay, this is one of a major problem in data structure that is, very famous and something that you should know if you are a data structure student. So when we say shortest path problem, it's a very common problem and where the question over here or the agenda over here is finding the shortest path of the problem with the solution. Okay, so let's take this example as of now because that example I think we have already done. So let's take a new example over here. So you see we are having approximately 9 nodes starting from 0 to 8 in various vertices. Let's consider our source node as 0. So initially what we need to do is we need to keep everything in a unsettled set. Okay, so there is nothing in SPT set as of now, and each and every node is having the distance value as infinity except the source node. The source node I am keeping over here is 0. So the value for distance value for the 0 will be 0 and for everything else will be the infinity. Okay. And now we have to again start traversing. Now let's try to do that using Dijkstra algorithm. So again, what it is telling you, the set SPT is initially empty and the distance is assigned to the vertices. So for 0, we are giving 0 and for rest of them, we are giving infinity as our distance value. Okay, where INF indicates infinity. Now pick a vertex with minimum distance value. So initially the vertex 0 is picked because that is our source vertex. We have given the minimum distance value as 0 for that and include it in a SPT set. So SPT set becomes, this including 0. Now after including 0 to SPT set, pick date distance value of its adjacent vertices. Adjacent vertices of 0 are 1 and 7. Okay. So just check the graph. So adjacent vertices of 0 are 1 and 7, right? So we need to actually pick up the adjacent vertices. We need to traverse the adjacent vertices and we need to update their distance values. Okay. So we'll update the distance value. For this it would be 4 and for this it would be 8, right? So the distance value of 1 and 7 are updated as 4 and 8. Following subgraph shows the vertices and their distance values. Only the vertices with finite distance values are shown. So see, the green one is something that we have already picked and stored in our SPT, and the red one is something that we are still into the traversal. Okay. So 0 is already included in SPT, 1 and 7 are currently we are traversing. We have updated the distance value. Now, after this stage, pick the vertex with the minimum distance value and not already included in the SPT. So, which one is not already included? Both, which is having the minimum distance value is 1 because its distance value is 4. Okay, so that means we'll pick up that one. The vertex 1 is picked and added to SPT set. So SPT set now becomes 0 and 1. Why so? Because now we have taken 0 and 1 and update the distance value of adjacent vertices of 1. So distance value of vertex 2 becomes 12. How that becomes 12? Now let's see that. You see over here. So since we have included 1 in our SPT, so we have to update the adjacent vertices. So the only adjacent vertices in this graph you see it is 2. Okay. Although it's like 7 is also there, but 7 is something that is we are still into traversing and we have already seen that it was giving 8 and we are on the 1, so that's why we are going to do for 2. Okay, I hope you got it why we didn't hit 7 because it's already in a traversal path. Although we have not included in our SPT set, but this is something we have already up to seen. We have seen and we have traversed. So that's why we are not going to touch upon the 7 one. And moreover, if you see if we are going to touch upon it, then also this is having the minimum one. So that's why we have taken an. So up till 2, the value is 12. Okay, now what we have to do again from 2 and 7. So see, now 0 and 1 is included in our SPT, but the vertex which are not included in a SPT but has been traversed are 2 and 7. So for both of them we have to actually see which is the we have to actually update the adjacent vertices. So pick up the vertex with the minimum distance value that is not included in SPT. Okay, so let's say vertex 7 is picked. Why vertex 7 is picked? Because so far you see that the distance value for up to 2 has become 12 and for 7 it's still 8. Okay, so this is the minimum, that's why we are picking 7 to be stored in our SPT. So now our SPT becomes 0, 1 and 7. So 0, 1 and 7 will be included in SPT. And now we have to update the distance value of the adjacent vertices of the 7. The distance value for the vertex 6 and 8 becomes finite, which is 15 and 9 respectively. How it is 15 and 9? So 7 has adjacent vertices which is 8 and 6. So 8 plus 7, 15, and 8 plus 1 will become 9. Okay, so something we have achieved. Now again we have to pick the minimum distance value which is not already included in SPT, which is vertex 6. Why? So because the distance value so far, if you see, is 9 over here. In other case it's 15, and if you see in the upper case it's still 12, which is still greater than 6. Okay, so now SPT has become 0, 1, 7 and 6. Now update the distance value adjacent to the vertex 6. Same, repeat the same thing for the 6. So distance value for the vertex 5 and 8 are updated. Okay, which become 15 and 5. Again you see which is the shortest one. So we can see that 5 is the shortest one because it's 11 over here, and for 8 it's 15, and for 2 it's 12. So we'll pick up 5. Okay, and so far we need to keep on repeating this. So after 5 we reach to this 4, and so after 5 if we reach to 4, so it will become 21. Okay, so finally this is the shortest graph that we have got. How we reached over here? You can see we were on 5. Okay, so from 5 we extended, and since the adjacent vertices was 4, 3 and 2. Okay, so we calculate for each of them. 2 is something we'll not take into consideration because you can see that 2 is something that we are already traversing. Okay, so therefore we'll see for 3 and 4, and we can see 4 is the shortest one, so we'll go till 4. But then some of the nodes are left. So from 4 we'll actually see which is the shortest one. So from 4 we can either go to 3. Okay, so 3 was the only choice. Or since this has already become 21, so the shortest one left was up till 2, which was 12. So up till 2 you see it was 12, right? And from here it became 21 by going to this 4. So then we are going to extend it from 12. So we have traversed till 3 and 8. Okay, so you see in the final minimum spanning tree, after continuing the same process, you see we have got a spanning tree which is including each and every vertex connected node with the minimum distance. Okay guys, so this is a program. So since this was a very lengthy program, not very lengthy but yeah, still lengthy, that's why I've just written it, and I'll be explaining you this program. So you see, this is our main function, and inside a main function, we have actually created a graph. Okay. So how this graph is created, it's actually a 2D matrix of int. And how it is created? Well, it's created using this thing, this graph. And how so? Well, I'll be explaining you that. So as you see that in this, I hope you do know that how 2D matrices are represented. So each element, if you just represent each element, this is actually 0, 0, this is actually 0, 1, this is 0, 2, this is 0, 3, and so on. Okay. Just for a 2D matrix, how do we represent 2D matrix? Well, each and every element we give an index. So what I'm creating is, I'm actually creating a 2D matrix from that graph to show you that how it can be represented. So you see these are the nodes that so we have nodes till 0 till 8. Okay, so these are the nodes that I have just represented, and now what I will be doing is I'll be either placing 0, or I can even leave it blank, and then I'll place the number wherever there is an index. So if I talk 0 to 0, so for 0 to 0 definitely for from 0 node to 0 node there is no such index. Okay, so this is not a circular graph, so there is no index. Now we'll see from 0, so this is like the base index from 0 till 1. So when I talk about 0 till 1, so 0 means 0 is your node and 1 is your the you can say, if I talk about source node and destination node. So 0 is source node and 1 is destination node. So let me see if there is something, any graph. So you see that from 0 and 1 we do have a graph, and the value for that is 4. So therefore I'm going to put 4 over here. Okay. Then we have to check from 0 to 2, like if source node is 0, then is there any node that is going to the node 2? If the source node is 0, is there any edge that is going to 2 or 3, 4, and so on and so. Okay, so let me check for 0 collectively. So if we see from 0, we have two nodes. One is like two edges. One is going to 1 with 4 as a value, and one is going to 7 with 8 as a value. There is no other node that is directly attaching to any other node. So let me put for 7 also the 8 value so that I can complete with my 0, right? And for rest of them you can put 0. Why so? That means because they are not having any value add. Okay. So yeah, it depends on you. You can keep it 0 or you can keep it blank. But since we are creating a matrix and we need some of the it to have some value, let me just yeah. So node is 7 and value is 8. Okay. So node is 7 and the values. So I hope so you got it. How I inserted 4 and 8 over here. Because from node 0 we do have a edge that is going to 1, and also we do have a node that is edge that is going to 7, and the value for that is 8. Okay. Now let's do the same thing for 1. So if I do the same thing for 1, so from 1 you can see it's going to 2 with the value 8 and going to 7 with the value 11. So it's placed. For rest I can keep 0. Okay, so this is the way that you need to create your 2D matrix. I'm just going to do for one more row, and for rest of them you can do it yourself because we have already created that kind of graph in our code. Node 2. From 2 you can see there are various nodes. It's going to 1 with the value 8. It's also going to 3 with the value 7. It's also going to 8 and it's also going to 5. So let's add each one by one. So firstly let's add 1 and 3 with the value 8 and 7. And then it was also there for 5. So you see for the 5 it's 4 and for the 8 the value is 2. Okay. And for rest of that I can put 0. In a similar way, you can just complete this matrix and at the end you will see that the result that you will get after completing this matrix would be something that we have written in our code, that is this. Okay, so let me just verify my first two rows. So you can see 0, 4 and 8. Okay, and rest of them are 0. So 4 is there on index 1 and 8 is there on index 7. So is ours, and same goes for the second line. We have 8, 11 over here. Okay, and yeah, 8 and 11, and yeah, there is also 4. So from 1 to 0, 1 to 0, let me check. Yeah, so from 1 to 0 we have 4. So we also need to include this while creating methods, although even we have traversed it before. So we need to put 4 over here. Okay, this is the correct thing. So finally, you can, keep on going through like that. So I want to give you an idea how we can create a 2D matrix from a graph. So finally, you'll get this matrix, okay, after doing all the mapping. So this is a graph we have got in a form of a Java expression, or you can say Java code. Even you can do, the arrays are also there in C and C++, so you can do the same computation even in C and C++. Okay, then I do have a class. The name of the class is shortest path, and then I have created a method in that which is Dijkstra. Okay, so because this is according to the Dijkstra algorithm. Now I am passing this graph whole and one index that is 0. Now let's see what we are doing in Dijkstra. Okay, so this is a Dijkstra code. This is a Dijkstra method. Let's see what we are doing in this. So this is a function that implements Dijkstra single source shortest path algorithm for a graph represented using the adjacency matrix. So this representation that we have done for our graph is also known as adjacency matrix. There is also one more representation for graphs, that is adjacency list. We'll be covering that when we'll be studying graphs in detail. As of now, you have studied that how can we create an adjacency matrix from a graph. Okay, now what we are doing in this method is, you see, what we actually need to do. We need to, firstly store the distance value of each and everything in as infinity except the source, which will be 0. Okay. And then we also need a SPT set which will contain our all the elements which we are including in our shortest path. So that is the thing you see we are doing over here. So we have created a distance array. Okay, the array to store the distance value. And what is v over here? Well, v is a type, so it can be any type. So this is like, generically created. It could be a string, it could be a anything. So it's actually defining the size of the array. So what size is that you can get to know from your main class. So if you see from our main class, we have defined as 9 because there are 9 nodes in our graph. So you can define the v over here as a static final variable, and then you can use it anywhere in your class. So coming back to the Dijakstra code, you can see we have actually initiated a distance value array, which is dist. Okay. So the output array dist I will hold the shortest distance from source to I. Okay. Then we are having spt set, where spt set I will true if the vertex I is included in the shortest path tree or the shortest distance from the SRC to I is finalized. Okay. So you see that SPT set that we are going to use is something, it's an array which is a Boolean array. It will contain true, like, if there are nodes from 0 to 8. Then let's say 0 is represented by SPT 0. And for SPT 0, if it is there in the tree, if it's there in a spanning tree, then it will mark as true. Otherwise, it will be false. So initially, it has to be false. So you see we are actually initializing over here in this code. So over here you see for SPT set, we are setting everything as false, and distance value we are setting for everything as max value. But for source, that is for node 0, we have to set it as 0. So after setting to max value, we are actually setting for 0 as or source as 0. And what is source? Where source is 0 initially. Okay. So eventually source will change, but for the first time, since we are passing it 0 from here, so the node 0 will be your source over here initially. Okay. Now, after that, what we have to do is, since we have initialized everything, the first thing that we need to do according to the Dijkstra algo is to find the smallest distance value and, add it in our shortest SPT. Okay, so how we are going to do that? So you see that there's a for loop which is going to, traverse to all the vertices, because it says while all the vertices are not traversed, you have to keep on repeating the step. So first step was to find out the minimum distance, the vertex. So to find the minimum distance vertex, we have a method minimum distance. In that we are passing both our arrays. So we are passing SPT set array and distance array. Now let's see how we are actually finding the minimum distance vertex in minimum distance method. So let me go to this. So minimum distance method is over here. So this is the minimum distance method. So what you can see in this, we are actually firstly initiating a integer min to a maximum value. So what is the maximum value? It's obviously infinity. So you can also keep a very long value over here as we have done in this case. And the minimum index that we are keeping is -1 initially. Okay. After that, we are taking a loop from 0 to all the vertex, and we are checking if SPT V is equals to false. So initially everything is false, means nothing is added in SPT set. So for that it will be true. Okay, I mean the condition will become as true because everything is false. So it's checking firstly that it should be false. That means this node should not be added in your SPT set. Okay, so first condition is this, and second condition is the dist v should be less than min. Why dist v? Because min value initially we have set it as max value. Okay, which is a infinity kind of value, and the dist v is the distance. So the distance should always be less than the min. Okay. So for first time you see that both the condition will be true for the zeroth element. Why? So because obviously everything is false and everything in dist v is actually equals to your the maximum value. So this condition will become true. So min will actually become 0. So the min is actually become dist v, which is 0, and minimum index will become v, which is again the zeroth index. So min index for the first time will return you 0. Okay. So first time 0 is returned. So let's go back over here. So you see first time the 0 is returned to u. So in u it's 0. After that we have to add it to SPT set. So how to add it? Well, we can do SPT set u is equal to true. That means for 0th element we have marked the boolean value in SPT set as true. That means it is added to SPT set. Fine. After that you can see that we are having, we need to actually update the adjacent vertices distance. Okay. So for that we are actually having a loop So this is a loop that we are having. And inside this loop, what we are doing is we update dist v only if it's not a SPT set. So we have to check it should not be in a SPT set. Okay, so I mean we should make sure that the vertices distance we are updating, any of the vertices should not already be in a SPT set. And there is an edge from U to V, I mean from the source there should be a edge because that means it's adjacent vertex one. Okay, and then the total weight of path from SRC to V through U is smaller than the current value. So the total value of the path should be like that from the initial source node till this node. So we are going through should be lesser than the current value. So these are the three conditions that we are checking. So you see in the if case, firstly we are checking that it should not be SPTV for this should not be true. That means it should be false, right? And after that we are checking the graph UV should not be null. That means it should not be zero in our graph. If it is not zero, that means there is a edge. Okay. And then we are checking dist u is not equals to integer max value. So that means it is something for which the distance value has been already updated. Dist u, okay, is not max value, and dist u plus graph uv, that is the current edge, and the previous sum that we have calculated till u is actually less than the dist v. Initially dist v will be infinity, right? So this will become true obviously. So therefore our dist v, the newly updated value, will become dist u plus graph uv. Okay, so that's why we are updating the value. Okay. So this loop will keep on continuing. Okay, everything is going to continue in a loop because we have to repeat the steps of, finding the minimum distance and setting it true and then updating the adjacent vertices. So after this is done, we are going to print the solution. So let me run this program to show you what is the output. So you see for the vertex 0, it's giving distance from the source as 0. From the vertex 1, it's giving the distance from the source as 4. For 2, 12, and so till 8, it's giving us all the distances. So we can, very well find, like, suppose if I have to go from 0 till 6th node, then the minimum distance I need to travel is 9. Okay, so I hope so you got the code. And well, I'm not kind of wanting you to copy paste the code. I want you to write it yourself. But in case you face problem, then yeah, you can easily find it on internet. So there is no confusion with that. Or you can, take I just scroll it down for you to just repeat it again. So we have three major components. One is main method. Then the class we are calling a Dijkstra method by passing graph and first index is 0. In the Dijkstra method, we are doing three things. So overall, first is initialization, everything to infinity, and after that we are doing three things. First thing that we are doing within a loop is finding the minimum distance vertex. After that, we are setting it to true. And after that, we are calculating the distance for the adjacent vertices. And we are repeating the same procedure till we have traversed all the vertices. So this is the logic that we are going. I hope so you got it. Okay guys, thank you very much for attending this tutorial. Let's meet in the next tutorial.